Welcome students to the revision session of chapter number 3, that is motion in a straight line. The very first topic in this chapter that we are going to cover is rest and motion. Rest and motion. Now what do you mean by the term rest? Rest is nothing but an object is said to be at rest if its position does not changes with respect to its surrounding with passage of time is called with passage of time. Example I can give over you: a book lying on a table. Clear? We're able to notice that suppose if these two markers are lying on the floor, though they are stationary, they do not move with passage of time, but you will able to notice that there are several force acting on it, because the force acting from upward is balanced by force acting from downward. That's why these two markers are lying at rest. Clear? The second is motion. Second terminology is motion. Motion is nothing but what? Object is said to be in motion if position changes with time. An object is said to be in motion if its position changes with respect to its surrounding with passage of time. Example I can give you: train moving on rails. Till this clear? The next topic we are going to study is point object. What is point object? Point object is nothing but the distance covered by the object is more compared to its size. Then you can say the object is point object. If the distance traversed by an object is large as compared to its measurable size, as compared to the size of an object, then object is considered to be point object. Point. Here, if distance traversed by the object is more as compared to its size, then you have to consider that is point object. In case of point object, rotational and vibrational motions of the object are ignored. Is this clear? Example I can give you over here: example number 1, the earth can be considered as point object. During its study of the motion around the sun. Because the distance traversed by earth around sun is more as compared to the size of the earth, then earth is considered to be what? Point object. Second, the train having journey of several hundred 100 kilometers can be considered as point object. Can be considered as point object. Clear? Here the size of the train is less compared to the distance between two stations. Hence this train is considered to be what? Point object. The distance traveled by the object is more as compared to the size. Then you can consider that object to be what? Point object. The next is rest and motion are relative terms. Rest and motion are relative terms. Why relative terms? You'll be able to see that an object in comparison with another object might be at rest, and with the third one it might be in the motion. That's why you can say that rest and motion are relative terms. I can give you one straightforward example. A passenger may be at rest to his fellow passenger sitting in a train and maybe moving for the objects outside the train, hence an object can be stationary with another object. An object can be stationary with respect to another object may be moving with respect to other object. Hence motion and rest are relative terms. Is this clear? Moving to the next topic that we have is mechanics. Next topic we do have is mechanics. Mechanics is nothing but the branch of physics. That deals with the study of object. Remember, at rest or in motion. Study of object at rest or in motion. It is the oldest branch of physics. Is this clear? Now mechanics category we have. Mechanics is further classified into the very first category, that is statics. Second is kinematics, and third is dynamics. Clear? The very first is statics. Let us discuss more about statics. It is a branch of mechanics. That deals with the study of object. Statics means stationary. Remember, at rest or in equilibrium. Here word is at rest or in equilibrium. It is a branch of mechanics that deals with the study of object at rest or in equilibrium conditions. Clear? Here, time is not essential. Here, time is not essential. Here, second branch we are going to see is kinematics. Second branch we are going to see is kinematics. Kinematics is a branch of mechanics. Kinematics is a branch of mechanics that deals with the study of motion of object without considering the cause for the motion. Without considering the cause for the motion. Here, the cause is not considered for what reason the motion has occurred. So, without considering the cause for the motion, here time is essential. Here the time is essential. Also, the kinematics is a Greek word. The kinematics is a Greek word. Kinema means motion. Is this clear? Next is dynamics. Dynamics is here it was without considering the cause for the motion. Here you can take into consideration the cause for the motion. Dynamics is the branch of mechanics. That deals with the study of motion of object with considering the cause for the motion. Taking into consideration, you can write more precisely, taking into consideration the cause for the motion. An important point is object is taking into consideration the cause for the motion. The dynamics is a Greek word, means power. Basically, dynamics deals with the forces that cause motion. Dynamics deals with forces causing motion. Force causing motion is studied under what? Dynamics. Newton contributed a lot in the field of dynamics. By giving his postulates and laws. You know Newton's first law, second law, third law, that are based on what? Dynamics. Next topic we do have is distance and displacement. Next topic we do have, that is distance and displacement. Distance and displacement we are going to study. First we are going to study what is distance. Distance is nothing but the actual path length, traversed by the actual path length traverse means to cover, traversed by the object between its initial and final position, positions. Clear? I can take an example over here. The distance traversed by particle moving from A to B via C. Suppose I can take that example where the two particles moving from A to B, but via C they have said. Via C means first A to C, then C to B. So I can say that distance covered that is equal to first what, A to C and then C to B. In this clear? Distance covered is A to C plus C to B. You will able to notice one thing over here. The distance is a scalar quantity. The distance is a scalar quantity. That is, it has only magnitude, but no specific direction. In this clear? The SI unit for distance is, the SI unit of distance is meter. The CGS unit of distance is, centimeter. Remember one thing over here, one important point. Distance traversed may be always be positive or zero, but never negative. Your distance can never be negative. I am putting down the point over here. Distance can never be negative. In this clear? The second term we do have with us is displacement. That is displacement. Displacement is nothing but the shortest path length directed from its initial position to final position. Okay? Our displacement is the shortest path length between initial and final position. That is nothing but the displacements. Is this clear? The displacement is a vector quantity, that is, it has magnitude as well as it has magnitude as well as direction. Yes or no? Direction. Direction means directed from initial position towards final position. Initial position towards final position. Is this clear? Suppose we take the same example. What is the same example? Suppose the particle moves from A to B via C. Then it is AC, BC. But if this is your distance, so distance can be answered as actual part traversed, that is AC plus CB. If somebody asks you displacement, then displacement, this is your initial position, this is your final position. So the shortest distance between initial and final position directed from initial to final, that is the displacement, that is equal to what? AB. Till this clear? Distance is equal to AC plus CB and displacement is shortest distance between initial position and final position, that is your AB, having specific direction. So vector specific direction we do have. So displacement can be denoted as AB, but remember there will be vector over here because displacement is a vector only. Is this clear? Next, the SI unit of displacement. The SI unit of displacement is meter. Yes or no? Is meter. And CGS unit of displacement is centimeter. Yes or no? Is same as distance only. Clear? Because both are length. Is this clear? Dimensional formula. Can anybody tell me what is dimensional formula? Only length. The measure of length answer is what? M0 L1 T 0. Is this clear? Now the next question we do have, that is the displacement might be positive, negative, 0, or you can say that the displacement can be smaller or equal to the distance but can never be greater than distance. That we have to prove by example. Displacement can be positive, negative, or 0. Displacement can be positive, negative, or 0. One more point you have to remember. Displacement is smaller or equal to the distance. Displacement may be, you can say may be smaller or equal to the distance covered. Now we have to take this example and we have to prove. We have to show that. So we will take an example. A car moving on x-axis as shown in figure. Here a car is moving on x-axis as shown in figure. $100, $120, $140. In this clear? It starts from O, it goes to P, it goes to Q. Here I am taking case A. Car moves from O to P. Now what is distance? From O to P? O to P means 20, 40, 60, 80. So distance is 80 meters. Distance is what? 80 meters. Yes or no? What is displacement? Displacement, that is nothing but what? Final position minus initial position. Yes or no? Final position minus initial position. Yes or no? What is final position? T. Initial position O. So T is 80 minus 0. So answer is how much? 80 meters. You will be able to notice that the distance and displacement are equal. Here distance and distance is equal to, you can say what? Displacement. Till this clear? Till this clear? If I am taking one more example over here, car moves from O to P and to Q. O to P to Q. You can say is this journey. O dash P dash Q. So again distance O to Q to P. You can say O to Q. I am taking one more example. O to Q to P. O to Q to P. Like this. So what is distance? Distance that is equal to O to Q means OQ and Q to P, that is QP again back. This is the start point and this is the finish point. So I am going to get O to Q, that is 140, and Q to P, that is 20, 20 and 20. 140 minus 80. How much you are going to get? 20, 40 and 60. Yes or no? So check over here, this gap is of 20. This gap is of 20 and this gap is of 20. So from P to Q distance is 20, 40 and 60. Yes or no? So my answer is 140 plus 60 is how much? 200 meters. Still this clear? Now if somebody asks me displacement in this case, if somebody asks me displacement in this case, and I can answer, this is my initial position, this is my final position. Initial position, final position. So P minus O. What is P? 80 minus O is 0. So my answer is how much? 80 meters. Here I can notice what? I can notice displacement is less than what? Distance. Is this clear? Displacement is less than distance. I can write over this case is nothing but what? Displacement is less than what? Distance. Is this clear? Your distance is equal to displacement. Is this clear? This was the example I have to see. We will see more examples in the next session. Thank you so much.